Okay. Hello everyone, so this is gonna be part 2 of the questions. Let's see where I left off. I guess I started here. Okay, so a ball is kicked with a velocity of 15 meters per second. The ball then strikes a vertical as shown. Okay. By considering the vertical motion of the ball, calculate the time it takes to reach the ball. Okay. So the vertical motion, we know initially that it's a vector like this, the 60 degree. The magnitude is 15. So we gotta split it up into vertical and horizontal. So the first part is gonna be horizontal. So v of x is equal to 15 meters per second times cosine of 60. There's going to be 7.5 meters per second. And then v of y is equal to 15 meters per second times sine of 60. Which is about 13 meters per second. So we're given that it strikes a vertical wall at the instant when the path of the ball becomes horizontal. So when it becomes horizontal, we know that, oh my god, I can't draw straight lines. This means that our vertical component is actually 0. Because we're only moving horizontally, we're not moving vertically, and since we're not moving vertically, it's going to be 0 meters per second. So using this fact, we can actually write a Suvat equation. So let's write Suvat here. So our acceleration is negative 9.81. Our time is, we don't know. We're trying to find that. Our final velocity is what we said above, which is 0 meters per second. Our initial velocity is right here, 13 meters per second. And then, yeah. So then we can actually solve for t here. Let me remember the equation. So we have a couple of equations. We have s equals u plus v over t 2 times t. This is for displacement. Maybe not the best. Maybe it's b squared equals u squared plus 2as, but we don't know what s is. There's ut plus 1/2 a. T squared is equal to s. Oh, okay, so it's actually this, I think. V equals u plus at. It's a carbon velocity. So we can actually use this equation here. So let's go ahead and actually plug in the values. So our v is 0 equals 13 plus negative 9.81 times t. And then we get 13 over 9.81 is equal to t, which is 1.3. It's actually 1.325, but by two sig figs, it's going to be 1.3. Explain why the horizontal component of the velocity of the ball remains constant as it moves toward the wall. There is no resultant force affecting the horizontal component. Thus, the vector never changes. I do. Alright, let's see. Thus the vertical component never changes. Show that the ball strikes the wall at a horizontal velocity of 7.5. So actually, we already calculated this in part 1. So it says explain why the horizontal component it remains constant. So since it never changes, our initial horizontal is the same as the final. So we know that v of x is equal to, or the u of x, let's say the u of x, the initial x component is equal to the final component. And since our initial is 7.5 units c of x, that's our answer basically. Okay. A ball of mass 0.42 kilograms is dropped from the top of a building. The ball falls from rest through a vertical distance of 78 meters to the ground. Air resistance is significant so that the ball reaches a constant before hitting the ground, and the ball hits the ground with a speed of 23 meters per second. Okay. The ball in B is dropped at a time t equals 0, and then hits the ground at t equals time. The acceleration of free fall is g. On Fig 3.1, sketch your lines to show the variation of acceleration of the ball when the time from t goes 0 to t equals t. So this is kind of like unit 3 actually, because of terminal velocity. So we know that our gravity is actually 9.81, which is right here. So we actually go on, and then as we reach terminal velocity, we're actually going to be actually I'm not entirely sure. Because it can be concave up or concave down. I'm pretty sure it's just going to be like this. And I'll explain why. So this is when we're actually free falling, right? And at this point, we're actually increasing our velocity as we're going down. But this segment right here signifies our reaching terminal velocity. So basically our acceleration and air resistance are slowly being canceled out. And then right here is terminal velocity. Okay, so I think that's it for unit 2. Currently I'm just second guessing myself because I feel like it's a little bit different than this, but we'll say that this is the answer. Yeah, so thank you for watching this video, I guess, if you are watching this video, who knows. So this is unit 2. I'm probably going to do more videos after this, so stay tuned, I guess, and sub, because like my channel, you know, struggling. So, yep. Have a good one, guys.